So let's first talk about vocabulary. There is a reason that you have adopted a curriculum. So even if you don't like math expressions, right? So you still may go rogue here and there, do some other lessons, but there's certain things that if you're not doing it in expressions the way that it was designed, and you're not doing it K6 or K5, depending on how you've adopted, you're actually greatly impacting your implementation process. One of the things when we talk about fidelity is, I want you to use the same methods, the same models, meaning a method, like if it's place value sections, or it's, talk about show all totals in the younger grades. Like there's specific algorithms or numeric methods that are introduced in expressions. There's usually about 4 per operation, and they're very important. Even things like measuring in 2nd grade, and we loop the ruler and we loop the number line, that looping comes back in almost every grade. And it's really handy when we get to 5th grade and we're multiplying and dividing fractions. So there's little things like that that are methods that actually grow with time. They go from the most concrete version to more of an abstract, like more generalizable method. But those are the things that make or break an implementation. So if we're using the same methods, okay, I'm using the same methods that 2nd grade is using, or everyone in the 1st grade team has decided, like, yes, we might actually add in some of our own methods and have a vertical progression or talk conversation about we're doing these ones. And we've also decided that this one is an appropriate one for our kids. Those are decisions you have to make, right? But the ones that are in the guide, you have to come to some sort of a consensus on. And so methods are something important. Models, if we're using a comparison bar, a break apart stick, a math mountain, all of those types of things are very specific. And once they're introduced in expressions, they don't go away. Okay, so when we talk about the methods, the models, and then the next thing I say is the language, and that's where vocabulary comes in. What we call it and how we call it that is important. And the more classrooms I'm in, and I've been in a lot this last 6 weeks has been a heavy travel season for me, lots of classrooms, lots of schools. And it just becomes really clear that many of us are taking shortcuts when it comes to vocabulary. We're not calling things what they are, right? And then we're upset when it shows up on a test or they don't know what that means. Well, it's because you haven't been consistently using that vocabulary. And this is about precise vocabulary, mathematical understanding. The better our vocabulary is, and the more we use it during our math class, the more deeply we actually understand concepts. So I'm able to name it and claim it different things. So I just want to add that to this conversation, that we have to also agree on what are we calling things and how are we incorporating it into our instruction, so that when I say, I now need you to, this is a break apart problem, kids don't look at me like I'm speaking a different language. They've heard break apart problem since kindergarten, right? But if I'm the only one using it because it's in my guide and I'm like, well, I think this is called a break apart problem. And they're like, what are you talking about? Okay, so because everyone had their own song and dance. So it doesn't mean people don't have autonomy and they don't add in their own flair, but it means we are agreeing on a certain amount of vocabulary. And so that K6 vocabulary that you see here, I think that'd be really helpful for you guys to decide, like, which ones are you going to use? So that all that to be said is that vocabulary is one of those things that we want to be really, really consistent with. And remember that a word wall is only helpful if you're going to make a wall of them. It's only helpful if you actually build it with students and you use it a lot. So I often will see people that have math walls and they put up these little cards and words and whatever, but even as an observer sitting in the back of the room, I can't even see that card. I don't even know what it says. Right. So I tend to go more of the anchor chart route, that as we are in the geometry unit, I'm creating an anchor chart with students, and every day as we learn something new, I might anchor it to my anchor chart. So I might say, so friends, remember today we talked about the 3 different types of triangles. We talked about a right triangle, an isosceles triangle, and a scalene triangle. Friends, let's anchor our learning. I'll draw one of each. We'll list characteristics underneath it. I'm going to color code my anchor chart. I'm going to build that with students. And then I might say, now in your notebooks, I want you to tell me the 3 types of triangles, and I want you to label it, color code it. What are the different words? Maybe there's an activity now I have them do, right? So it has to be meaningful, and it can't be something that we're just front loading the lesson with. So I know I'm coming into my math lesson. I'm like, oh, today I know that we're going to be talking about expanded form. Friends, let me really quickly tell you what expanded form is. Instead, I challenge you on that. I think that our intuitive language, what we would naturally call things, what we would naturally say about something, actually helps us understand the topic way more than when we have this word out there, but it hasn't been connected in our brains. We're not connected to any synapses. Like, it doesn't mean anything because we haven't had to do anything with it yet. Right? So instead of front loading your lesson with vocabulary, just hear me out for a minute, that you let kids experience the math. Okay, so for example, I was in a third grade room this week and we were in unit 3 and we were building 3-digit numbers. And in that unit, or in that lesson, we were using secret code cards. So we would build with the blue cards, like 300 plus 20 plus 6. I'd say, build 326. And those are the 3 cards students were supposed to use. And then they were using their quick draws, right? And so I said, okay, so when you put the numbers together, like after they built 326, we checked the back of the cards matched the front of the cards. Like, we were exploring like what all we know about this number 326. And then I'd say, now I want you to stretch it out. And I want you to pull those cards apart. And so the teacher I was co-teaching with, Miss Allen, hi, if you're watching, she did a great job of this, but now we're naming it. We're saying, so that's called expanded form. Everyone, expanded form, stretch it out. Now we're adding total physical response, TPR. We know this is so good for kids' brains, for our EL learners. There's so many good characteristics of putting our words to movements. And then something that's kind of catchy like that. So we said expanded form, stretch it out. And guess what? Throughout the entire lesson, we would say, okay, next number, we'd read the number, boys and girls, build it in expanded form. Everyone, what's expanded form? Everyone would do it. Everyone would say it. Then that goes on my anchor chart. So friends, our new vocabulary today, you just figured it out. When we take each one of the place values and we spread them out by its place, that's called expanded form. Boys and girls, turn to your neighbor and teach them what expanded form is. They have to do more with it than just put it on a word wall, do a definition of it, write it in a notebook. But in too many classrooms where we start the math block with kids in notebooks, just writing down, like literally copying the teacher from the whiteboard into their notebook about this vocabulary. I don't have anything against putting it into a notebook, but what a waste of time when it's not meaningful. They haven't even done any math yet. And that copying, the looking and copying onto a piece of paper takes a lot of working memory. So for your struggling students, it is not a good strategy, right? Maybe taking a picture of your anchor chart and printing it off for those kids and they just put it in their notebook. That's probably better for those kids that are really struggling with working memory versus copying it down. But my goal is for you is that what if you actually have them do the math first, like experience the 3D shapes and figure out like how many sides and corners it has. And so now what do you think we call this? Then name it because they just had an experience with it. It means something now. And then once we name it, we anchor it, right? And then when we anchor it, we list all the vocabulary that goes with it. So as you're thinking about vocabulary cards and math word walls, just decide, like, am I using it frequently? Because if I'm not using it frequently and having my students say those words frequently and use them when they're up at the board and they're explaining their ideas to someone, if I'm not doing that, that's a dead word wall. It's just a waste of space. Okay, it's decoration to them. So instead, I need them to use the vocabulary. So I'm going to give you a couple of ways that you might do that, some additional thoughts on this. Okay, so another thought here would be that you have kids use like a Frayer model, right? So again, after I've learned it, okay, so I want you to go with me that we're talking about triangles and maybe I'm in kindergarten or conversely, I'm in 5th grade. Like we talk about triangles in both of those grades for very different reasons. So as we talk about, let's just say even an isosceles triangle in 5th grade versus just a triangle in kindergarten, we're going to talk about all the attributes of the triangle and what do we know about it, right? Well, then I can put it into something I would use in ELA and vocabulary, like a Frayer model like this. Now, I've changed the Frayer model just a bit to match what I think works with vocabulary in math, but you can make any of these 4 squares, whatever you want. But these would be great things for kids to put into a workbook that's not just write a definition. This would be great to have on your anchor chart, right? So I put this big square here because I'm thinking if they had those vocabulary cards that they would tear out from their workbooks, that'd be a good use of it. Okay, so it could be they just tape that vocabulary card right in there, and then definition, examples, non-examples. It says other words I can use to describe it. Turn the page, do another Frayer model. Here's pictures of it, or I could do the picture of the definition card. That's the other part of the card in the vocabulary cards. There's a word card, and then there's like a picture card. That picture card that has a meaning of it could go into the definition, and then students could write what they know about it underneath the picture. Right? So now I'm going to write the definition. Then I'm going to give examples. What are other examples of triangles? And if we're in kindergarten, we know they really struggle with triangles that are not equilateral triangles. They only ever see equilateral triangles that look like this, the points at the top, that's a triangle. But as soon as I change some of those angles and I turn it, all of a sudden they're like, that's not a triangle anymore. Okay, so I need examples. What are all the different types of triangles? In kindergarten, small triangles, large triangles, fat triangles, yellow triangles, green triangles. Those are all examples. Those work. Those are all triangles, even though they kind of look differently. And fifth grade, I'm going to isosceles triangles. What is an example of an isosceles triangle? And show them with different rotations, because they don't always look like, straight up and down. Like they just don't. So giving examples. The non-examples. What does it not look like? If you really understand what something is, you only understand it because you really understand what it's not. Okay, so like kindergarten, under non-examples, we would draw circles, and we would draw squares, and we would draw polygons that are open. Like, we know a triangle is a triangle because it's a closed figure, right? So anything that I'm like, nope, that can't be a triangle, because now I'm going to incorporate math talk. And I'm going to say things like, well, that's not a triangle because a triangle, and then I'm going to use all the words on the right-hand side, other words I can use to describe it. Okay, so a triangle, I might do attributes, like it has 3 corners, it has 3 sides. If it's isosceles, right, I talk about how it has 2 equivalent sides. Like I'm using all of that vocabulary, because then when I say, now use the vocabulary that you said, other words to describe it, or other meaningful vocabulary words, when I say, so why is it not this? And I point to something on your non-examples list, you have to use the vocabulary from the right side to say why it's not. So let's just say we wrote down here, we wrote about, it's 3 sides, and we wrote 3 corners, and we put all this other vocabulary here. Maybe we use the word equivalent. If I'm talking about isosceles, maybe I would talk about angles. Okay, I use other things. I talk about other ways that we could describe that triangle. Well, then I say, so why is this not a triangle? And I'm going to say you have to use this vocabulary to prove why this is not. So you say, well, it's not a triangle because it doesn't have 3 sides. You're right. Why else is it not a triangle? So everything they put in the non-example, they have to defend using the other vocabulary words that really are attributes that prove to us why a triangle is a triangle. Okay, so the idea is just that students are doing way more with this vocabulary, and it could be like a station in a small group time that they're doing that, or you just build it as a whole class. Like you're anchoring the vocabulary together. You come together at the end of your lesson and you say, so friends, you summarize the learning. You maybe had an exit ticket, or maybe that is your exit ticket. And you say, so we learned that today, expanded form. And everyone's like, stretch it out. Let's anchor it. Let's put it on our anchor chart, nice and big, where everyone can see it for the whole unit. Let's give examples. Let's give non-examples. Is it still expanded form if it's 9 plus 30 plus 300? Or is it only expanded form if it goes in order of place value? Those are good questions, good conversations. Anchor it. Okay. Or do something like the Frayer model. Kids can just make it themselves. So as you're thinking about additional vocabulary here, put something in the chat that's resonated with you, something you just heard that you're like, now I get it. Okay. Or I haven't thought about doing that before, or here's another way I use it. Let's share some ideas together. Lastly, you might see something like this. So specifically my squad members, I just doing a quick note for you guys. Don't forget that I have made you other large vocabulary type posters that could go on an anchor chart, or go in a resource notebook, or just go on your whiteboard as you're talking and discussing words. After kids experience it, then we name it. Right. And so don't forget that these are there. They're at the point of your lesson, like in the middle of the area lesson. I have that poster for you, 3rd grade, or in the middle of discovering rectangular prisms. You kind of get the point. They're also often under the unit resource section in the squad. So don't forget that vocabulary support is available for those of you who are in the squad to help just make it brighter, colorful, larger. So I kind of gave this idea already, but if you're thinking about vocabulary, remember, like if I was talking about triangles, we just taught on triangles. Now I'm going to list the vocabulary and I'm going to say, okay, now I want you to teach it to your partner. I want you to teach what a triangle is. And I want you to try to use as many of these words on the screen as you can. I want you to draw them. I want you to point to them. I want you to define them using this vocabulary. That is a focus on precision and getting kids to really attribute the words to the attributes and to understand it more clearly. Just because you named it, just because you wrote it down in a journal, just because you gave it a definition does not mean they understand the word. They have to use it, and they have to use it a lot. Okay, so another example, this is what is this? Fill in the blank. You can use a sentence frame. I know because, so this is a triangle. I know because, and then you say, by the way, you have to use these words as you fill in that frame with your partner. We're increasing the amount of math talk that's happening in our rooms. I'm really am a big fan of sequencing and selecting work. So I prompt this particular story problem. I say, I want you to solve it however you would like. I get these 3 different types of work. They're all actually the same. And they're different. How are they the same? How are they different? So as students go to explain and to compare and contrast other students' methods, I'm going to give them a frame. They are the same because, and then I'm going to give them the vocabulary to help plug in. So as you compare, they're the same. And they're going to say things like, they're the same because they're the same problem. Okay, but now go back and use my vocabulary. Oh, now you're looking for, well, what can I say about the add-ins? How are all the add-ins the same? And what else could I say about the total? And if I have an anchor chart, I already have like a Math Mountain written and it's labeled Math Mountain, and I have partner total, and then I have it renamed add and sum. And I have an anchor of that so that if they don't remember what an add-in is, they've got it anchored in the room where they can go see. And they're like, oh yeah, that's what an add-in is. Oh, let me look at these 3 examples, which like, how are the add-ins the same in these? Okay, so that would be a great way to use it. Use your vocabulary as you talk about expanded form. Okay, so stretching out, place values, hundreds, tens, ones. How could you explain expanded form using this vocabulary? I've started doing more of this in the squad. So for my Math Genius Squad members, this is from 4th grade. This is towards the end of their year, but in geometry of, okay, let's talk. There's so much vocabulary in geometry, but putting in some words, giving examples, but then saying in your slide decks, now use these words as you teach your neighbor everything you know about rays. Okay, again, the more you use it and the more precise you are, the better you're going to have understanding and be able to use that vocabulary to really enrich your learning. That's more effective ways, regardless of the curriculum you use, that we can be utilizing more math vocabulary in our math classrooms. All right, friends, have a great Math Crush Monday. Take care. We'll see you soon.